Hello and welcome to another free code session. My name is Jason Bach and I can't let things go. I was editing the video from the last episode and I was talking about some optimizations I did on my code for Advent of Code. And one of them I started to think about even more, even though I said, no, I'm done, I'm finished. I'm not going to do any more optimizations. One of them I just couldn't just let that problem fade away in my head. It was the one with the blizzards and the elves moving in directions and trying to find a path. And I was thinking about it and going, how could I change this? Especially when I started looking at like the allocations and the fact that I was making a new grid array every loop. And I thought, could I make this better? Could I do anything more here? And so you're seeing some notes I have here about things I've been thinking about. And so I'm going to use the next episode or two or whatever to get this to work. It's going to require a fair amount of bit manipulation. So I got to make sure I've got my ducks in a row to do this right. So one thing I realized is, well, how can I get away from doing another array allocation every single time? And I started to realize, well, couldn't I store in another 4 bits the new locations and then move those down? That way I don't have to keep reallocating a new array. And I thought, yeah, I think that should work. I'd have to use a constant because even though my enum is a flags enum, it's going to start creating new values that really aren't that enum value. So fine, whatever, I'll just create 4 constants. And that's great. But then I said, well, since I only need 8 bits, let's use a unsigned byte. And I quickly found out that there are no operator overloads for and or things like that. I was a little surprised. It just doesn't exist on those. And if you try to do it on them, it does casts for you. And I'm like, I don't really want to do that. If I have to use a 32-bit number, then okay, fine. But then I said, wait a minute. If I'm using a 32-bit number, that means I have 4 sections of 8 bits. Why don't I just store 4 values, their new ones and their current ones? And I'll have to be a little bit more conscious about like if it's moving right or left and down and up, and the down and up won't be too bad because the Y direction is going to still be the same, but the right and left, I'm essentially scrunching it into 4. So if I had 100 elements, like going from 0 to 99, now I'll only have 0 to 24. So I'll be saving some, which is nice. So do that. And I thought, so I'll still have to go through the array twice because as you see in my comments down below, I have to at some point say, okay, I figured out where the new locations are. Now I have to move those down 4 bits and say those are the current locations for the next part to do its work. I thought I could do that while I'm figuring out the new locations, but I couldn't. I actually tried to record this episode and I had to stop because I realized, no, that's not going to work because you might be moving values over and that integer, that 32-bit number actually hasn't been updated yet. And then how do you keep track of what is actually being updated and what isn't? And I said, nope, that's not going to work. So that's actually a good note to say, yes, sometimes you just want to go in and code something up and see I mean, that's what I do in these episodes is sometimes I just go in, but I'm also trying to be a little bit more intentional when I do these episodes and spend more time thinking about what I'm about to do rather than just go into it and get frustrated. Now, even doing this, it's potentially going to get a little just tricky again to make sure I'm landing on the right bit to and or and do all the shifting and stuff. But I think this will work. And again, I've spent a lot of time thinking about this. So we're going to give this a go and we're going to see where this lands. By the way, did you know that there is an int 128. There's actually 100. I think there's a uint as well. If I go to uint 128, is there? Yeah, there's an unsigned integer version of this as well. So there's 128-bit numbers now, and excuse me, and they're basically they're just two u-longs shoved together, and yeah, I was like, oh, okay, well you could have a uint 256, which isn't there yet, but there's now a 128 read-only struct, which I thought, that's kind of cool. So I just stumbled across this because as I was going through this, I got to the point where I'm like, well, I didn't want to do that, go through the array again and bit mask and shift over on every single value. Is there a way I could do this all in one shot? And I got this wild idea of, well, why don't I just use a big integer and just tell it to bit mask across some arbitrary hue I can't talk. Go across this arbitrary bit mask of a certain size, but a big integer is essentially a wrapper around a unsigned int array. So it still will go through every one and do that. So you're not really gaining a lot by going that route. And that would have been even harder to figure out, how does a big integer encode all of the grid? So we're not going to go there, but we're going to do the idea that I came up with before. So what we're going to do is take this and we're going to copy that. Again, we're not going to do the full expedition, which maybe I could do that off camera at some point if I want to. We're going to say optimized one grid. Okay. So now here, when we do parse optimized, I think I'm not only going to, well, first of all, okay, I got to have to say Blizzard direction values. So what we need here is a public const uint Blizzard direction left, which we're going to just copy these just because there's no real reason for that, but there we go. And then we're going to have right, up, and down. Okay. And so it'll be that, it'll be that, and then it'll be that. And this will be right, up, and down. Okay. And then we're also going to need a clear, oh, that's funny. There's a spelling mistake there. Okay, because we need 4 bits and then 4. Okay. This is going to be the clear current mask. It's going to public const, not cubic, public const uint clear current mask. And that's what that is. Okay. These are all just giving errors because, and these, well, hold up there. Whoa. Back up the horse. I was not being a C# coder there. I was being something else. There, yeah, they have to actually be in a class. Who knew? So I should have. Okay, so here we're going to do a parse optimize. Now I think I'm actually going to have to return, parse optimize one grid, because not only do I have to return the grid, but I think I'm also going to have to return, because I was thinking about this today. Today was a day off for me, and I was just thinking about stuff like this. Who does it on their day off? Is if you have like 102 characters, well, that last entry in your array, you need to have 26. But that last entry in the array only holds 2 numbers. So you're going to want to know what the original X size was, because that will help, I think, in determining, to make my algorithm a little bit more general, to say, well, how many sets of 8 do I have in this unsigned integer? Okay, I think that's what I'm going to need. So I'm going to have here a uint, and we're going to call that a grid. And we're also going to have an int x length. Okay, one grid. So here we're going to be doing a new uint, except we're not going to go across the entire input. The 0 here is because we know everyone is going to be the same. They're always the same length across. But what we want to do here is say uint, I think there should be a div rem, yes. And what do you get out? The quotient and the remainder. So we want to have var quotient remainder of a uint div rem, where we're getting that and that. Okay, because we're going to store 4 in each one. And what don't you like about that? Oh, fine. Cast to a uint. Doesn't matter. And now what we're going to say is the actual length here is going to be if remainder is greater than 0, then it's quotient plus 1. Otherwise, it's just a quotient. Because you could have had 100 and divided by 4 gives you a remainder of 0, so you're at 25, and you don't have to worry about any of that stuff, okay? And the whole input length, that's the y direction, so we're good, okay? Now, when we initially create the grid, we want to put the things in the current location. So those will be the lower 4 bits. And I know how I'm going to do this. I'm going to do it for you, the viewer, so that it's right. The 0th will be the lower 8 bits. And in that, the lower 4 bits has the current and the upper 4 will have the new. And then the first value, you'll have those 8 bits, second and third. The 4th will be in the first by index, or the second element in that XY grid. And then the 0, 1, 2, 3, 4 will be the lower 8 bits and so on. Okay, so that's what we're trying to do here. So what we want to do is say that the line length is on the input, but we really don't want to do that. What we want to say is the length. Well, no, I'm sorry. I'm actually wrong here. We do want to do the entire length. But what we're going to do here is say, okay, well, what X are you at with all the characters? And then mod that so that we know what we want to individually div rem that so that we get that quotient remainder, so that the quotient tells us what the index is and the remainder tells us how much we have to shift over on the bits. Okay, so hopefully that made sense. So we're going to do var X quotient and X remainder on, we want to do X div. Yeah, you're not going to do that. Sorry. And that makes sense because X here is going to be an int. Yes. So we want to say int div rem, and the value is going to be X here, and the right, the value which divides. Yes. 4. Okay. So this will tell us now if it's 0, 1, 2, 3, the quotient should be 0, and the remainder is going to be just the remainder. So this grid at X quotient, and then at Y, is going to be the character at there, except here what we're going to do is say SD24, Blizzard direction right, except you want to shift it over. And the amount that you want to shift it over is the remainder. Yes, if it's 0 divided by 4, the remainder would be 0. If it's 1 divided by 4, the remainder would be 1, and so on. So we want to do a X remainder. I believe that's correct. Because if we say 1 and we shift it over 0, that's exactly where it should be. Okay, I think I have that right. I'm just anticipating so many so many bugs with this. And this should be up. And this should be down. Okay. I don't know what the IntelliCode was telling me there, but now in this case, I don't think we do anything. I don't think we would, in that group of 8, We're assuming that it's already 0, so we shouldn't have to do anything. And how do we do that? 0 over x remainder. Yeah, it doesn't like that. Cannot implicitly. X remainder is an int. A 0. And we're putting into the grid that. Can you cast this to be a uint? It's not going to like that. No, it doesn't let you do that, which is not surprising. But this is bringing up a good point, which is operator cannot be applied to operators of type uint. And does an unsigned int not do a left shift? Okay, fine, it doesn't. So whatever, we're just going to make these ints. I mean, the only reason I did them in the int is because it is unsigned, the 2's complement negative number, but really we're just saying 32 bits. We don't care what the actual number is so long as our bit shifting is fine, okay? So this is going to become an int. And then this will become an int. and this will become an int. Yay. Okay. And so then this does that and we're good and wonderful. There's a part of me that just goes, something's going to break. Oh yeah, because these are uints. And so now we want these to be int. And what don't you like there? Cannot. Oh, for God's sakes. I get what it's saying here. It's because this is too big to fit into an int. That would be fine. Oh my Lord. Oh my days. Can you cast that to an int? No, it won't even let you do that. Constant value, that big thing, cannot be converted to an int. Use unchecked syntax override. Yeah, I want you to... I was going to throw in another cast there. That would have been brilliant. Well, I just want bits. I want these numbers just to be bits. And just, you know what? Let's just go back and just make these all whatever. And you can shut up and let me just... There. Was that enough? Yeah. And then this was... just do another one. Why not? I'd love to just be able to say here, like, do nothing. Because it's a 0. And that shifted, like... you went? You gonna shut up now? I hope you do. I really hope you do. These are always going to be in the lower 4, so I hope that works. And is this doing like a separate allocation for God? Would you please just let me do this? Hold on, I gotta look this up again. Hold on. Okay, right here it's saying those operators are like these are defined for the int uint long. So, like, what am I missing here? Why did it say, unless it interpreted, I did like 5 or 10 minutes of work for no good reason. It's a Friday and I had the day off and I'm just feeling kind of giddy. Okay. So why are you... Oh, yeah. It's a length. Okay. So I think we have done this correctly, which is, well, no, we haven't. We've only done that correctly for 1. See what I'm getting at? This X remainder tells you, oh, you're the 0th of 8 bits. This is 1 of 8 bits. This is 2 of 8 bits. Okay. But that's not enough. It's this times 8. So when it's 0 times 8 is 0. When it's 1 times 8, it's going to be 8 over. That's what we want here. Come on, IntelliCode. You can't pick that up. Are you kidding me? Okay. We can say var x shift is equal to, well, doesn't matter. I mean, it's going to do this here, and it doesn't like do it 5 times. It's only going to do it for whatever the character was that it found. Okay. So why is this barking here? No, I don't want to replace it with a jagged array. Why would I do that? I'm sure there's... See, by the way, this is the thing. I thought that when I was doing advent code, I have an editor config here, right? But what I didn't realize is when I was going through all this is, okay, that, but then I come here, and I treat warnings as errors as false. I don't know why. I think it was because I didn't want to struggle with too many errors while I was coding. And Jason, bad boy, you know better than that, okay? So that's why I still have all these, and I've had no desire to go through and change them all again, which again is a clear indicator that you should always have that as true as soon as you start any new project. I think it was Jared Pearson's that said, warnings are just errors that lack conviction. And I totally believe that. Okay. So yes, I think we are going to be doing now the right thing. So we get the first character in. That would be, yes, 1 times 8, which would be 8 over. And then the 0, 1, 2 character comes in. As it'll be 2 times 8, it's 16, it moves over. So this is putting everything in current positions. Now, why are we getting the length back? The length, well, we already know what that is. That's from the grid. We're telling you, oh, yes. Oh, yes. That's what we really want here, is that extra length there. So what is it that we really need to come back from this? We need the grid, obviously, but I can't just tell you that there were 26. I have to tell you that there are 26 and either 0, 1, 2, or 3. Well, actually, no, that's not correct. If it was perfectly on, like 100 characters long, it'd be 100 divided by 25, so the remainder would be 0. So that's basically telling you that the last digit had 0. Now, what I'm trying to do is find a way this to report back and say, how long was this really? And I think I just literally just said it, which is this. That's how long the original array was. That's, I think, what I was looking for there. Okay. And so then I can use that to say when I'm going through to know the last array, or to make it more generalized to say, as I'm going through, I think there's a way I'm going to be able to figure out to generalize it and then say when it gets to that last element in the array, do I do all 4? Do I just do 3? Do I just do 2? Or do I just do 1? I wouldn't do 0 because otherwise that element wouldn't exist. Okay. So I know I haven't done a lot here. I've been doing a lot of explaining and screwing up because I don't understand which operators are on which type. But what I'm going to do next is I'm going to write a little test and just pass in a string input with just one character and see does it do the right thing, because it's going to be really important this stuff is correct. And then once I've got that down, then we're going to start to do the next step. So this may take a couple of videos, who knows, but I'm having fun. Thank you all for watching. Leave comments and questions below. See you in the next episode.